All right, moving on to the last part of, or the second half of chapter 8, we're going to do a lot of factoring with different types of things. But today we're going to start with factoring using the greatest common factor. Okay, so factoring with GCF, we're going to start with these two examples. Okay, we're going to start by doing factor trees. Okay, but after you do a couple practice ones with factor trees and you can do it without them, you're going to get to that point. Okay, so you're not going to have to do them every time. So raise your hand if you know what I mean by a factor tree. Okay, so what a factor tree means, I'm going to look at number 1 first. We want to find the greatest common factor of 12 and 18. What that means, we want the highest number that goes into both of those. Does anybody have any guesses right now? What's the highest number that goes into 12 and 18? It is 6. Okay, I'm going to show you how to find that if you didn't know. So what are two numbers that multiply together to give us 12? 2 and 6. Is there either of those that I can break up more? 6 goes to 3 and 2. Can I break up any more? No. I'm going to circle those so I know that I'm done. So 12 is done. Now let's do the same thing with 18. What are two numbers that multiply to give us 18? 6 and 3. And then we said we could break up 6, right? So we have 3 and 2. And I'm done with both of those. So I'm going to circle those. Now, what you're going to make is your list. What are the things we circled on 12? 2, 2, and 3. Every one I circled, even if they repeat, I'm going to write them down. Okay? And I write them in numerical order. Okay, 18, what do we have on 18? 2 and 3 and 3. Okay, now, greatest common, you want to highlight what they have in common. So out of their list, what do they have in common? They have a 2, so I'm going to write 2 down here. What else do they have in common? A 3, so I'm going to write a 3. Okay. Do they have anything else in common? No. So now take 2 times 3. 6. Which, is that what we said before? Yes. So if you already knew it without the factor trees, that's great. But if not, you can use factor trees until you get more comfortable figuring them out. Okay? Questions so far? Let's look at number 2. What's different about number 2? Has variables, okay? So we can still do the same thing with our factor trees. How can I break apart 10? 2 and 5. Can I go any farther? No. And what I also want to highlight is what do they have? It has x also. Okay, don't forget about your variables. So I'm just going to put that underneath my tree so I don't forget. Okay, what about 15? 5 and 3. And those we can't break apart farther. And then how many x's does it have? 2. So I'm going to write 2 x's at the bottom so I know. Okay, now make your list like we did before. What does 10 have? 2, 5, and x. 15 has 3, 5, x, and x. Okay. Now that we have our factors, we want to do what's in common. What do they have in common? A 5 and an x. Do they have anything else? Nope, so multiply those together. 5 times x gives us 5x. Okay. Any questions so far on finding the greatest common factor? So, factoring, you can think of it as the, what are the words? Reverse distribution. Okay, so what we've been doing so far is distributing in those terms. Now we're going to take out those terms. Okay, so we're going to do that example with our 5x here. Okay, so we found our GCF was 5x, so I'm going to take 5x out. Because we started with this, I'm going to factor. Our greatest common factor was 5x. Now I'm going to divide both of those terms by 5x. So what's 10x divided by 5x? Just 2, right? If I write this on the outside, I have 10x divided by 5x. Those x's cancel out, and then 5 goes into 10 2 times. Okay? And then plus, what do I get when I divide 15 and 5? 3, and then x squared divided by x. Just regular x, right? You can think I'm taking it out. So I started with a 10x, I'm taking out a 5, so I'm left with 2, and I took away an x, so there's nothing left on the inside. Same thing here. I divided my numbers, and then I took one of the x's away, so I'm left with one of them. Okay. Why they call it reverse distribution is because if I distributed back, what would happen? Yeah, we would get back to our original. Okay, so factoring is kind of putting it in terms of a simplified version. Okay? Any questions so far about GCF? Okay, let's look at an example here. Are we ready to try it on our own, or do we need to do another one? Okay, I'm going to challenge you, find the GCF first. If you don't want to make the factor tree, you don't have to, but if you need to, you can. Okay, raise your hand if you're still doing factor trees. Okay, that's okay. Let's break it apart a little bit. Take it one step at a time. Look at your numbers. So I'm going to look at 27 and 18. We want the highest number that goes into both of those, which is what? What? 9. Does everyone agree with 9? Okay, so 9 is for our numbers. What about our y's? How many y's do they have in common? Only one, right? So I just want one y on the outside. You're going to take your smallest exponent value, if you want to think of it that way. Take your smallest exponent value because you only want the ones that they have in common. Okay. I'm going to come over here. So 27, what does 27 break out to? 9 and 3. What does 9 break out to? 3 and 3. So we're done there. What else did 27 have? The 2 y's, right? Okay. 18 breaks to what? 9 and 2. What does 9 break to? 3 and 3. And then what else did I have? 1 y. Okay, so I'm going to make my list. 18 had what? Yep, 2, 3, 3, and y. What did 27 have? 3, 3, 3, y, y. Now, when we get to the greatest common factor part, what are we looking for? What they have in common. What do they have in common? A 3, another 3, and a y. So that gets us 9y, which is what we had up here. Okay? Again, you do not have to do the factor trees. Only do it if you need to. Okay? So coming back up to our example up here, what is our next step now that we found our GCF? We want to factor now. Okay? So again, take it one at a time. What's 27 divided by 9? 3. I started with 2. I took away 1. How many y's do I have left? 1. Then we have plus, what's 18 divided by 9? 2. I started with a y. I took away a y. No y's left. So then I'm done. How can you check if you got your answer right? Distribute it back, see if you got it right. So we take 9y times 3y, 27y squared, and then 9y times 2, 18y. Okay, highly, highly recommend using that to check yourself. Okay, since this is one of the first times you're doing it. Okay, let's look at number 2. Now, sometimes the numbers are going to be really big where you have to use the factor trees, okay? But on number 2, do we need to go to a factor tree? No, right? Because they're smaller numbers. What's the greatest common factor of 4, 8, and 2? 2, right? Because 2 goes into both. Let me switch my number. 2. But now we have to be careful with our variables. Okay, so I'm going to highlight my A's. This one has 2, this one has 1, and this one has 1. You want to take your smallest amount. So how many do they have in common? They have 1 in common, so I'm going to take 1 out. Now look at the B's. This one has 1, this one has 2, this one has 1. What's my least value? 1, so I'm going to take 1B out. Okay, can I take anything else out? No, that's my GCF. What is my next step? We're going to factor it out, right? Take it one at a time. We have -4 divided by 2. -2. A squared divided by A. Yep. And then we have B divided by B, which is just 1, so there's no B's left. Now move on to our second term, -8 divided by 2. -4. A divided by A, none. B squared divided by B, B. And now we're on our last term, right? What's going to happen on the last term? Right, what's 2 divided by 2? 1. A divided by A, none. B divided by B, none. So we're done. Okay, so take everything one step at a time. Okay, figure out your GCF of your numbers. Figure out your variable, and then figure out your other variable. And then take each term one step at a time. Okay? One other thing you need to look for is in here, you want to make sure you can't take anything else out. So did we account for everything that we can take out? Yes. Okay? When you have 3 terms, just like we had there, you have to compare all 3 at the same time. You can't just compare 2 of them. All 3 have to be in common. Okay? Again, how can you check if you did it correctly? Distribute back. Okay, let me show that process one more time. So we take 2AB times -2A, A squared B, so we're good there. 2AB times -4B, so we have -8AB squared. And then 2AB times 1, just 2AB. Okay, again, if you have to do factor trees, keep doing factor trees until you get more comfortable. Okay? Any questions so far? Don't try and do everything at once. Take it all one step at a time. Okay? I want to look at one more. Go ahead and try this one on your own. So, take it one at a time. Let's look at our numbers first. I have 7, 21, and what do I technically have on the third one? A 1. Okay? We want the greatest common factor. What is it? Why is it just 1? Right, 1 can go into everything, and we can't take anything else out of 1. Okay? Always look at your smallest number and then go from there. Okay? What do we look at next? The U's. We have 2 here, 1 here, and 1 here. So how many do they have in common? Only 1. Take the smallest one. Okay? Now look at your T's. 2, 2, and 1. We want to take 1 out. Good. So now we're going to start our factoring, or our reverse distribution. Okay, so take it one term at a time. I'm going to look at this one first. What's 7 divided by 1? 7. U2 divided by U. 1U. And then we have T squared divided by T. T, right? Okay, now I'm done with that one. I'm going to move on to the next one. So what's 21 divided by 1? 21. U divided by U. It just cancels, right? T squared divided by t. T. Now move on to your last one, but what's the sign in front of that last one? It is negative, so I'm going to have minus 1 divided by 1, 1. U divided by u, none. T divided by t, none. So I'm going to close there. Why do we have to have the 1 there? Why can we not put anything there since everything canceled out? Because of the negative, right? Even if it was a positive, we still would have to have that 1 there. Okay, because that term, if we distributed, okay, if I distributed and there was nothing there, could we ever get back to here? No. Okay, so that's why a 1 has to be there. What are the 2 ways you can check if you did it correctly? Distribute back, and then how can you check this way? Check if you can take anything else out. Okay. Questions for the good of the group?